Well, hello. Back from vacation. It's quite cold in Chicago by comparison to where I was before, but we're making do. And I've got a puzzle today by GDC. It's been way too long since I've had a GDC puzzle on the channel. And this one came in and it has modular arithmetic in it, which is perfect because it's going to be kind of in theme with the fiddler this week. So hopefully I can get another modular puzzle for Thursday as well. Anyway, let's get into the rules. So uh, there's there are two rules, but they're going to apply to every single line in this puzzle. So of course, normal Sudoku rules apply. If you have the digits 1 to 9 in every row, every column, and every marked 3 by 3 box. And then these lines have two variants on them. They're region sum lines, which means for this line, for example, the sum of these two digits will be the same as the sum of these three digits. In other words, when a line crosses a box, those box lines demark sections of the line that have the same sum. So in this one, for example, this is going to have three distinct sections that all have the same sum. So these two digits will sum to the same value as those two digits, will sum to the same value as those three digits. So that's the region sum part. And then there are zippular lines, which I think was first, it's kind of a combination of a couple rules that I think Heliopolis was the first to do. Um, and basically, they're like zipper lines. So a zipper line would be from the center, every kind of pair of digits away from the center will total the same sum. So for example, this were 9, we might have 4 and 5 over here, 6 and 3 here, and then maybe 4 and 5 again over here. So that we have sets of sets of digits that sum to 9 in the middle. But these are not quite zippular lines. They're not quite zipper lines, rather. They're zippular lines, which means that instead of having the same sum, they have the same sum mod 3. So if this were a 9, these two digits could sum to 9, right, like 4 or 5. Or they could sum to, say, 3. They could be 1 and 2. Or they could sum to 12. They could be 4 and 8, right? As long as the modularity, mod 3, of the sum is the same as the center, we're okay. And so I'm assuming throughout this puzzle, I'll be referring to groups of cells. That's very, very common kind of way of thinking about these lines. And I'm going to talk about the 0 group, the 1 group, and the 2 group. And so for the 0 group, I mean digits that are 0 mod 3. So that's 3, 6, and 9. The 1 group will be digits that are 1 mod 3. That's 1, 4, and 7. And the 2 group will be digits that are 2 mod 3, which are 2, 5, and 8. And if I have any other kind of shorthand thoughts, hopefully I'll talk about them as I think about them. But let's get started. I mean, because of the region sum nature of these lines, I'm immediately drawn to this really big line. These 5 digits here have to be at least 15, but because there's only 2 digits here, they're at most 17. And so I can't have a digit more than 7 on the line in box 5. So that means 8 and 9 are both going to, I'm not going to keep that marked, but 8 and 9 are going to be in these sections. They're not in the middle. Um, and I'm thinking that the modular nature of this line will tell me what the number is, but I'm trying to think through how that might work. Um, I mean, not obvious. The thing that first strikes me is if it's more than 15, so 15 is the smallest it could be. If it's more than that, I only have one choice for what these could be. So this isn't right, but so for example, if it were 16, in 2 digits, the only way to make 16 is a 7-9 pair. So, I don't know if it's 7-9 or 9-7, right? It could be either way. But this would take this form of something like A, B, B, A. And then because of the modularity, how would that work? Is there any way this could, I'm thinking, is there any way this could be BA like this so that B sums with each other and A sums with each other? I think no, because if it's, but that's kind of particular to the way 16 and 17 work. So if it's 16 or 17, we're going to have 9 with either 7 or 8. And whichever way it goes, I can't sum B with B and A with A and get the same modular sum because one of them is going to be 9. Let's say B is 9. Then that sum's going to be 0. And then A will either be 7 or 8. 7 and 7 would be 14, which would be 2 mod 3. And 8 and 8 would be 16, which would be 1 mod 3, neither of which would be 0. So if we're in the world where it's 16 or 17, we're in a world like this, A, B, A, B, A, B. And then I know them. I mean, if I know A, and I don't know which way A and B are, but I would then know the modularity of these two from these two. So these B and A paired with these A and B to end up with the same modular sum, either 1 or 2. And the same thing here. So this would have to be the same modularity as B, because it's pairing with A, which would be the same. This would be the same modularity as A. So one of these would be 3 or 6 to pair with the 9, and the other one would be 1, 4, 7, or 2, 5, 8. I'm not sure if that's actually helping us figure that rest out. I mean, what's left is just those 3, which seems very promising, but I can't quite wrap my mind around the final step there. I mean, maybe this is right, and maybe we'll end up finding that it has to be this way, and it'll be very restrictive, but I'm thinking it won't be allowed to be that way, but I can't see why yet. Maybe I can do something with the different number of groups I can generate. So this line has in one way kind of 6 modular groups, in one way 4 modular groups. And by that I mean I have these 4 groups. I'm going to color this green, yellow, purple, and peach. Okay, so these 4 different regions here, which are the region sum line. And these all that have not just the same modular sum, but the exact same sum. So whatever that sum is, I can multiply it by 4, and all of these digits together will be some number times 4. And so if this is 15, which is one possibility, then that's 0 mod 3. If you multiply by 4, that's still 0 mod 3. So that means all the digits together will be 0 mod 3. If it's 16, that's 1 mod 3. If you multiply it by 4, that will still be 1 mod 3, which is nice. And same thing with 17. With 17, that's 2 mod 3. If you multiply it by that 4, that's 8, which is still 2 mod 3. So whatever the modular sum is of each of these 4 regions, that's the same as the modular sum of the entire total. But I can also divide this up a different way, right? So I can divide this up by this modular zipper line. I'm hoping this leads to something, or it's kind of a big explanation for nothing. And there are 6 of those. 1, 2, 3, 4, 5, 6. So whatever, I don't know what this digit is yet, but whatever it is, if I multiply it by 6, that's right, 1, 2, 3, 4, 5, 6, then the modular sum, because if I add these 2 equations together, I don't know what each one is individually, but if I add them together, those have the same the sum has the same modularity as green. The sum of blues has the same modularity of green. So these 5 digits are basically 3 times green, 4 times green, 5 times green, 6 times green. Yeah, so that is it. So whatever it is, I don't know whether this is 0, 1, or 2, but if I multiply it by 6, I'm going to get to 0, because 6 is 0 mod 3. So the sum of all the digits together is 0 mod 3, which means each section has to be 15. It can't be 16 or 17. So these are all 15 groups. And this is also 15, which means they're 1 to 5. Okay. And now I think I can say that this one is not 6, 9. Because, oh no, that's wrong. I was thinking this had to be 3, but I don't think that's true. Hold on. Let's think a little more carefully here. Yeah, no, that's not true. Okay. But I do know that maybe we should have kept that coloring. So I do know that these kind of pair together in a nice way. And so these two together will match green. These two together will match green. These will match green. Is there a way I can figure out, like 6, 9 seems very hard in any of these because it means the other two will have the same as well. So if these are 6, 9, these are also 6, 9. Which maybe is okay, actually. If this is 6, 9, these are the same. And then I don't know if it's 1, 4 or 2, 5. But it would be the same. And that would leave 3 here with something else. 3 would be in the gray, with the something else would also be here. And that seems okay, actually. So if this is 6, 9, let's say this is then 1, 4, it doesn't matter. This would be 2, 3, 5. 2 or 5 here, 3 with the other. Yeah, that works. Maybe 7, 8 doesn't work here. So if this is 7, 8, these have to be different. I mean, I could fairly easily do that with a 3 here. Yeah, no, it all seems to work. Okay. Oh, no, that's not true. I was going to say because I know the modular sum of this, I know the modular sum of this. That's not quite right. I know the modular sum of this subtracted from this, sort of. So, what do I mean there? So let's say that this is 1. Let's say green is 1. Then that means the blues sum to 1 and the pinks sum to 1. So these together sum to 2. Well, I know this sums to 0. So that means this sums to 2. So basically, these are going to sum to this times 2. Whatever, is that right? So if this is 2, these are 0. Then this is 2. Yeah, this is 2. This is 2. This is always going to be 0. The sum of the 15 is always 0. So the sum of these is always going to be 2 times green. And that's part 0. So these sum will also be 2 times green. So if this is 1, oh, there we go. That's the problem. No. Hold on. No, this could be 1, 0, 2. I was thinking if this is 1, these would both have to be 1 as well. But 1, 0, 2 would work. 1, 0, 2, 0, 1 works. Except does 0, 2 work with this? So 0, 2 would have to go, if this is 1, yeah, 0 would go with the 7 and 2 would go with 8. That does work. Okay. Maybe that's just all I can do here. It seemed really promising. Can I do something similar here? So this has, I just have so many more possibilities for the region sum here, but I have 3 sections here. So the sum of everything together is going to be mod 0 again. But this time because of the region sums, not because of the individuals. And then this is 1, 2, 3, 4, 5. Okay, so actually, does that tell me that this is 3, 6, or 9? I think it does, because this number times 5 has to be 0. 1 times 5 is 5, which is not 0. 2 times 5 is 10, which is not 0. So this is 3, 6, 9, actually. Can this be 9? If it's 9, that could be 15, which works. Okay. Okay, but I know at least that's 0 mod 3. And that means these sum to 0 mod 3, these sum to 0 mod 3. Maybe I should think about that for all these. These seem too short. This has 2 and 3. So by the 3 again, the whole thing is, okay, so this is also a 15. Well, I guess I already knew that. Just if I had filled those in, I would have seen those were 30 and that's 15. So this is also 15. So this is 15. Okay. So these are all fairly small, actually. These are all from 1 to 5. Maybe we should be coloring lows and highs. Seems like I can do a lot of low-high work here. So there's at least one high digit here, which makes sense. But this is actually not that big. So 1, 2, 3, 4, 1, 2, 3. So again, all of these sum to 0 mod 3. And this is, this times 4 is also 0 mod 3. So this has to be a 3. And then these will either be, so that's not 3. This will either be, yeah, these will be one of each kind. So maybe I should start I'm going to start coloring modularity. So I'm going to call peach my 0 group. And I'm going to start coloring these 1 and 2. Oh, no, I was going to say, no, that's not helpful. I was thinking I know that these 2 are different groups now because these are different groups, but I don't know how these correspond to these. So I can't really color them very effectively yet. Let's see. Oh, but I now know that these are different. So like these are different kinds of 15. Sorry, these are not necessarily, these are all kinds of 15s, either 6, 9, or 7, 8. I don't know which is which. But this is different from this, obviously, because they're different 4 digits. But this is also different from this. So these two are actually the same. Whichever they are, they're the same. And these are the same. Ah, okay. Because if these were different, one of them would be 6, 9. And so let's say this was a 6, 9. It doesn't matter which way it is. If this was a 6, 9, these are both 0 mod 3. So I'd be adding the same 0 to both of these in a modular sense. But one would be 7, one would be 8. So these sums would be different if these were different. So all 3 of these are actually the same. I'm going to make that pink to remind myself. I'm going to get rid of this coloring. That's not what I wanted. I wanted color. Delete the color. Okay, so these are all the same type of 15, whatever that is, which is this one as well. And this is the other one. How does that help? I don't know how that helps. Let's see. Is there any way 3 is over here? I think it's hard for 3 to be here. So if 3 is here, this can't be 6, 9. The pinks can't be. If 3 is here, we can't have 6, 9 in the pinks because 3 is 0, would pair with pink, which is also 0. This would have to not be 0 because there's only one 0 in this whole line. This would not be 0, also paired with 0, so that would break. So 3 couldn't be paired with 6, 9, but could a 3 be paired with 7, 8? So that would make this 1 or 2 in a modular sense. I think that could work though. Let's say this is 1, 3 with 1, which would be 7, and then 8 could pair with 2 to get 1. Okay. So this would be 3, 2. Oh no, but then hold on. 3, 2, 1. And then I have 1, 2 left over. That doesn't work. So maybe there is something, maybe I can think about this a little bit. So hold on. Okay. Sorry, I should have seen this earlier. So this is this times 2, we said before. So if this is this times 2 in a modular sense, then I have 1, 3, 4 of this. And 4 of this sums to 0 mod 3. So it can't be 1 or 2, because 1 times 4 is 4, which is 1. 2 times 4 is 8, which is 2. So this is actually the 3. And so now, okay. And now these are different, which means these are different, which means the pinks are different, which means the pinks are all 7, 8. And this is 6, 9. Nice. Very cool. That's a very cool chain of logic there. And so now that means these are the same. And they can't be 3, 6, 9, because then if these were in the 0 group, the 0 group would be completely taken in the column, and this would also have to be in the 0 group because 0 plus 0 is 0, which is impossible. So this is all one group. It's either 1, 4, 7 or 2, 5, 8. I don't know which. And then these two would be in the other and the rest of it. So 3 is here somewhere. With the other of 6 or 9 and the thing that's missing here, which would be 1, 2, or 4, 5. Okay. Okay. This is 15 in 3 digits. Oh, and it's 15 in 3 digits all of the same type. So it's not 3, 6, 9. It's not 1, 4, 7, because that's 12. It's 2, 5, 8, which is 15. So this is 2, 5, 8. That makes this 7. That makes this 1, 4. That makes this 2, 5. I still don't know which way this goes, actually. But it will kind of correspond to these. I kind of want to label these like A, B, A, B. Maybe I should do modular coloring now, actually. So if this is, let's do green and peach. Well, let's do purple and peach. Don't love that. Okay, purple and peach. Then in the modular grouping, purple is always going to pair with peach to add to 3. So if this is peach, this is purple. That's peach. This is peach, so this is purple. That's peach. But I don't know which those are yet. Okay. This is 8. So this might suddenly be restricted. This might have to be 9. How would this work? So, I guess real quickly, these will be a 1, 4, and a 6, 9. Okay. So this works because it's funny because because it's in a region sum sense, this is the sum of those two digits. It's also true of a modular sense. So this is the modular sum of those two. But this is also the modular sum of those two, which makes me think we might end up with like a 3, 6, 9 chain here or something. I'm not sure that's the only way to do it. So I'm trying to think through how this works. So let's label this A, B, C real quick. A is B plus C, again in a modular sense, and B is A plus C. How does that work? If A is B plus C and B is A plus C, I think that means, does that mean A and B have to be 0? Or does it just mean A equals B? It might just mean A equals B, which is less helpful. So how could this work? 4, 1, 3 doesn't work. So A can't be 4. Wait, right? 4. 4, does 4, 3? No, 4, 3, 1 doesn't work either. No, sorry, 4, 1, 3 does work. 4, 1, 3 does work because 4 is the sum of 1 and 3. If this is 1, that's the sum of 3 and 4. Yeah, that does work. Okay. Yeah, so I think it just means A equals B in a modular sense. Okay, so that's not as useful as I thought. That means this, so that, what can this be then? It can't be 3, because if it's 3, it's 2, 1, which doesn't have A equals B. If it's 4, we can have 1, 3. If it's 5, we can have 2, 3. If it's 6, that doesn't work, because we can do 3 here and another 3, which doesn't work. Can't have 7 or 8. We can have 9 and then 3, 6. I think that's it. I think those are the only things that work, which is actually a lot of things. But before I go on without deleting this, I want to make sure that A equals B is right. And there's no other way to get this working. So A equals B plus C, and B equals A plus C. Yeah. So A, because C equals A minus B and B minus A. So A minus B equals B minus A, so that's B0. Okay, yes, that works. That works. And then, okay, so we've got some modular coloring. What's next? 7, 8, that's not 8 at least. Okay, let's see what this can be. I don't think this can be 12, because this is 12. 7, 8 looks here. This has to be 5, 7. But this would also have to be 12. And then what would I put here? Um, it couldn't be 3 and 9, because 5 and 7 are in different groups. Could it be 4? Could it be 4, 8? Like, does 4, 8... 4 would have to pair with 5 and you have to 7. No, that does seem to work. Hmm. No, but 7 doesn't work. Hold on, I did that wrong. This has to be 3, 9. Ah, no, this has to be 3, 9. If this is 7, 8, this has to be 3, 9 like this. Sorry, if this is 12. If this here is 12, that's also 12, which because of this has to be 3, 9. Sorry there, I had to cut for a little family thing. So let's see if I can remember what I was doing. It was a few hours ago that I was doing this. So I think this was. Sorry, I should have thought about this before I started recording. I think this was an example. I don't think that was right. I think I was looking at what happens if this is 12. If this is 12, because if this is 3, 4, 5, then 7, 8 would make this 3, 9. Yeah, that's what I had there. And this would also be 12. So this would be 4 or 5, this would be 7 or 8. These have to be, that doesn't work because these are both 0 mod 3 and neither of these are. So that doesn't work. Okay, but is that really helpful? Not sure if it's helpful or not. Let's see. Well, then 5 can only go with, because whatever 5 is paired with would be 3, same with 4. So 5 would have to be paired with 1, 4 would have to be paired with 2 if they're in there. So I'm wondering, can I say it's not 3, 5, 1 or 3, 4, 2? Because that would tell me which of 4 or 5 is here. Let's see. If this is 3, 4, 2, it certainly can't be 3, 4, 1. I'm eliminated 3, 4, 5. So if I can get rid of 3, 4, 2, I can get rid of 4. And that would place 4 over here, which would be nice. So let's see. If this is 3, 4, 2, that's 9. How do I get 9 here? It's either 3, 6, or 4, 5, because 7 and 8 are taken. 3, 6 won't work because those are both 0 mod 3. These would both have to be 0 mod 3, which won't work. So it would have to be 4, 5. So if this is 2, 4, this becomes 4, 5. And then what does this become? This has to become, can't be 3, 6. It has to be 2, 7 or 1, 8. I think either would work though. And obviously 7, 8 would have to go up here because of this. This would be 1, 2. I think that just works. What about 5, 1? 3, 5, 1 is also 9. So everything else applies. Okay. Can I get rid of 3, 1, 3, 1, 2? That's 6. This is 2, 4. These are 2, 4, and 1, 5, and that works great. Okay, maybe that was just a bad tree to bark up. Or maybe I had some thought that I can't remember now. Okay. This is, since these have to be different types to add up to 0, this is a type that's 2 or 5, so this is 1 or 4. Okay, so these do have to be, well, I already knew, those have to be different types. Those are different types. Yeah, okay. I'm trying to remember, I'm starting to remember where I was. Let's think back about this one. How did I get this 3, 6, 9? It was that 1, 2, 3, 4, 5 of these had to equal 3 of something else. So 3 of something else is definitely going to add up to 0 mod 3. So that had to be 0 mod 3 to multiply by 5 and get 0. Can I do more than that? What is this? I guess by normal Sudoku, I know 3 is here. Um, let's 7, 8. I get a 7, 8 pair down here. Does that help me at all? 7 and 8 are both in here. Okay, so the purple 7, 8 has to be over here. Ah, this has to be 7, 8 by Sudoku. So I was coloring these for modularity, but because they're 7 and 8, those are actually the same digit. So that's here. And so this one is here somewhere. Can I still have all the 7s and 8s? So the purple one is one of those. I think I run out of steam pretty quickly, though. Well, can I get rid of, because I now have one purple and one pink here. I wonder if I could get rid of like 4, 1, and 5, 2 by saying none of, if that's true, then none of these would be that color. I don't see why. I don't see why that would be a problem. Okay. So what do I have over here? I have 2 of each of these. So I have 1 here from 1, 4, 7, but not 7. So I have one of these digits are 1 or 4. One is 3, and the other is whatever's missing from here. Other thing that's missing from here, in other words, this cell. Sorry, and then this cell goes over here with the other 2 digits that are missing from here in 1, 4, 7. Yeah, it seems not great. What is the next step here? This probably can't be a 1, right? So this is 1. We're suddenly in 1, 9, 10 territory. 1, 9, and then they have to sum to 0 here. So 1 would need a 2. So this would be 2, 5, or 8. It wouldn't be 8 because this would be 10. So this would be 2 or 5. 9 would need 3 or 6. 2 and 5, 3, and so it would actually be 6 already. So we need 6, 2, 2. That doesn't work. So this can't be 1. Small victories. Can it be 3? Now we can get up to 12. It's a lot. Suddenly it's a lot of possibilities. We can just get rid of 1. Going up even a little bit makes a lot of possibilities here. Okay. Is there any way this is 9? If this is 9, this is 15 at minimum. This is at most 15 because 7, 8 are taken. So if this is 9, we get 1, 2, 3 here, 6, 9 here. This has to be 1, 2, and 3 here. 6, 9. These would have to be 6, 9 as well. Oh, that does break. So this can't be 15, so that's not 9. So sorry, let me just explain that again. If this is 9, the lowest this could be is 15. The most this could be is 15, because 7, 8 are taken, so that'd be 6, 9 is the most it could be, which is also 15. So if this is 9, these are all 15. But if this is 15, it's a 6, 9 pair, which means the zipper complements would have to make these digits add up to 0, and these are also 0. So these have to be 0, but 3 is taken in the box and the row. So these would have to be 6, 9. So this is already 15 plus whatever this is. So that doesn't work. This is not 9. Can I do something similar with this peach 7, 8 to say it's not here? I don't know what that gets me though. 7, 8 are both up here. My 7, 8, 7, 8, 7, 8. So at least one of them's on here. And it can't be both are on here because this is at most 15. So if that's 15, that's already too big. So this is 7 or 8, definitely. The other one's on here with some other stuff. So there's no 9 up here, actually. So 9 can't be on this because 9, 7 would make 16, which is already too big. So 9 is off of that region sum line, which puts it up here. Which means we get at most one digit that's 0 mod 3 here, which means I have at most 1 here. So if this is 3, this becomes 6 automatically. And then if 6, then this becomes at minimum 6, 7, 1, which is 14. And I can't give 3 anything to 14, so that doesn't work. I don't need a 6 on here. I could put 6 here. This could be 6, 9. Okay. So what is this? Could this be 4 now? If this is 4, this is either 6 or 9. But this becomes 1, 2, 5, which it can't be. That's weird. So if this is 4, this is at minimum 10. So this needs 6 or 9 at least. So this becomes a 4. This becomes 1. So this becomes a 3, 4, 6, 9. If this is a 4, this becomes a 3, 4, 6, 9 triple, which means this is a 1, 2, 5, which breaks this. So this isn't 4. So this is the 6, 9. It's this 6, 9. So these are now from 3, 1, or 4. This is probably 6, 9, right? This is probably, no, we said that doesn't work, right? This can't be 15. Or do we only say that in the context of this being 9? No, because I can have at most 1. So this is 6, 9, this is 6. Because there's at most 1 digit that's 0 mod 3 in those 3. And this needs 1. So this has to have a 6 over here. So now this is just a 7, 8 pair. And now this is already quite big. So it probably has to be 9, 5, 6, 7, 1, right? Because this can't be 6, 8, 1, because that makes this 15, and these are both 6, 9, which it can't be. This has to be no more than 5. So the smallest this could be is now 14, 6, 7, 1. The largest this could be is 14, 9, 5. So that is what it is. And do those work? 7, 5, and 7 are 12, which is 0. So this needs something from 2, 5, 8 to work. This is going to add up to 14. Let's see, 2 is going to be in here, which makes this 5. Gets rid of 5 from here. 2 is definitely here. Yeah, of course. 4 just works. The other 1 or 4 is here. It doesn't tell me this, unfortunately, because these could both be the same modularity. Okay. This adds up to 14. These add up to, I mean, it just is going to work. I was thinking, could I do something with modularity, but that's already fixed here. So if this is 8, this will add up to 6, which should be 1, 2, 3, 1, 2, 3. That seems okay. If this is 2, these add up to 12. I don't see any obvious way to limit that. Okay. Oh, this is not one. Oh, sorry. So what is this? This is actually, oh, it's the other, oh no. Sorry, that's 7, that's 8. I did something weird here. This is 5 or 9. That's not 5. Of course it's not, because the 5 is placed in the box. This is now 4. Wow. That is weird. That's not 3. That's the 3. Sorry, I think I'm still a little discombobulated from leaving and coming back. That's not 4 anymore. So the other 1 and 2 are here. Let's see what is in here. Whatever's missing from here and whatever's missing from here. Okay. And the rest goes here. I should know one more digit in here. Probably, nope. 6 is in there somewhere. Oh, but I know this now is now 9. And didn't I do something up here with 9s where I kind of knew what this was somehow? This can't be 7. It can't have 7 already in it. So it's got to be 3, 6, or 4, 5. 3, 6 doesn't work because these would both need to be 0 mod 3 to add up to 0. So this is a 4, 5 pair, which means these are, this is 1, 2 with 7 or 8. Yeah, okay, I remember that now. 4, 5 makes that 2. That's now a 1, 8. That puts a 1 on this line. Okay, so now this probably is 8, 1, 2, 3. No, it can't be now. That's 3. That's 6. So that's 2. What is it? 7, 9, 5. And then that makes this 4 and 2. Makes this 5 and 4. All right. Hopefully I didn't make a mistake. I might have made a mistake here. I'll go back and make sure I didn't, but it seems like that worked out okay. This now needs a 1 in it for sure, so that's 2. Oh, I have a 1 right here. Yeah, okay, so that's 2, and that sets all these to 8 because of the same modularity in purple. These are 7s. This is now just a 1, 4 pair. I'm going to get rid of the coloring. And this is now a, what is this? This is a 2, 5, 9 triple. 2, 3, 4, 5, 6, 9. Yeah, okay. This is the only thing I have left that really does something. It's just a modular zipper. There's no region sum component. Everything else is just Sudoku. So I should be able to do this. What are those 3 digits? These are 3, and 3 in the row is taken up. So these now are from 6 and 9. So I know the modularity of this. So these are the same modularity, whatever that is. So it's either 1, 4, or 2, 5. I guess it could be 3, 6, 9. 3 is taken here. All right, let's just systematically do some Sudoku. 1 gives me that. I get a 1 up here. 1 gives me the 4 here, which gives me 4 in here and 1 in here. Yeah, so I just have that X on 1's left. 2s. Need 1 here. Not there. Yeah, not enough to do much. 3s, I get 1 here. I get them here. That's all I get. 4s. No, I get a 4 here, which puts a 4 here. There we go. So those are 4, and I get a 4 of X wings left. 1, 4. It's either 1, 4 here, finishing that, or this is 1, 4, and this becomes something else. What's next? 5s. I don't see much else I can do with that. I guess I could put that there. 6s. I guess that's not 6. Oh, and this becomes a 5, 6 pair, which puts a 6 here. I should have done this row first. That's an 8. This becomes 7, 9. I know how that goes. Is this really 5, 9? Yes. This becomes 2 or 6. Oh, hold on. Sorry, the way I kind of do this in my head is I eliminate things from what's left, but when I have a digit that I didn't realize I had, I can mess with that. So I just want to make sure, because this 5 sees all this. Let me just back up and make sure I didn't make any mistakes. Okay. That was all right, I think. This becomes 9, 5. Yeah, this should have been 7, 9. Did I play something here before somehow? Oh, right here, yeah. 9, 7, 9. This becomes 2, 6 still. Then this is 3, 7. I think that's okay. This should be from 1, 6, 9. 9, 6, 9. 1, 6 makes this 9. I should know the other digit here. No, I broke it. Shoot. Oh no, what did I do? I don't know what I did. I don't know what I did. Why do I have 2 1s here? Okay, I have 2 1s in here. Sorry. I should not break in the middle of recording. Why did I get 2 1s there? I should have placed the 1 here. I don't know what I was thinking. Okay, let's try this again. Let's try this again. That's the 1, 2, 4. I still want to get rid of my coloring. Oh, no. Before I do that, I want to place the 7s and 8s. 2 makes it 7, 8, 8, 7, 7. Now I want to get rid of the coloring. Okay. This is a 1. No, it's still broken. What am I doing? What should that have been? 3, 6. No, it's just broken. No, it's just 3, 6. Let me just go back and make sure that 1, 2, 3 wasn't doing anything. Because that 1 has been there so long. Yeah, okay. I don't think that 1, 2, 3 was doing anything. I just filled it and I didn't use it. Okay. Yeah, that should be 3, 6. This should be 2, 5, 9. Do I still get a 3? Yeah, I still get a 3 in the row. These 2 digits are 6 and 9 still, but 6 is in this 2, 6 pair. 9, 6, 9. I should know each pair of these. This becomes 1 or 6. And this should become 4 or 7. Does that work in the column? Yes, it does. Okay. I'm trying to be a little more careful here now that I've made a ton of Sudoku mistakes. This can no longer be 3. That's a 6, which makes this 2 and 5, just like before. 2, 5, and 4. I could have done the 5 and the 4 from the 8 and 1 as well, I think. Does that work? 12, 6. Yeah, that works. 5 fixes these. These digits are 3, which is here. 4, which is here. 7, 8, 9. That makes this 9. 3, 7 over here, 2, 6 here. This can't be 9, right? If that's 9, that's 3. But I know that could be 3. Okay. This isn't 1 anymore, because that can't be 1, 4, or 7. Do I get more? I have to get more. 2 makes this 5. So this is 9, this is 3. If it's 2, it doesn't work because 5 and 8 are taken. So this is 9, 6, 3. 4, 7, 2, 4. Let's see, that's not 2. That's not 3. That's not 9 or 5, so that's 2. I get 6 telling me 2, 6. This is an 8, 9 pair. And then we have 2, 5 and 4, 6. Oh my goodness. Are there mistakes? I don't know. I'm just going to check. Oh, wow. Sorry, GDC. I really flopped the end there. I feel like I was doing okay before that. So thank you. If you watched me struggle through basic Sudoku, you must just like watching me suffer. So anyway, thanks for watching. Thanks GDC for setting. This is a really great puzzle, even though I butchered the end of it. And I hope you come back. See you later. Bye.